Hello everyone. Today we are going to analyze this frame using Kani's method. Before analyzing, let us see the frame one time. In this frame, there are two stories. In the beams, we have uniformly distributed load 18 kN per meter. In the columns, there are no loads. The first story is 4 meter height. The second story is also 4 meter height. Length of the beams are 8 meter. The moment of inertia for the columns is I. The moment of inertia for the beams is 2I. Now let us find the fixed end moments. Only in the beams we have loads. In the columns we don't have loads. So in the columns the fixed end moments are 0. For the beams BE and CD, we can find the fixed end moments using these formulas. This frame is symmetrical. The line of symmetry passes through the center of the beams. In this analysis, we can take any one of the side, either left or right side. I am going to take the left side and do the analysis. Let us name the center of the beam CD as G, and let us name the center of the beam BE as H. In this frame, we have only fixed supports. So the stiffness formula for all of the members will be 4EI upon L. First, let us find the stiffness values in the joint C. In the joint C, first let us find for CB. Length of CB is 4 meter. Let us apply that. Finally, for the stiffness of CB, we are getting EI. Before finding the stiffness of CG, we have to calculate the stiffness for CD. Length of CD is 8. Let us apply that. The moment of inertia for CD is 2I. So in the formula, instead of I, we have to apply 2I. After the calculation, we are getting EI. To find the stiffness of CG, we have to divide the stiffness of CD by 2. When we do that, we are getting 0.5 EI. Now let us find sigma k. For that, we have to add these two values. After adding, we are getting 1.5 EI. Now let us find the rotation factor. The formula is minus 1 upon 2 into k upon sigma k. We have calculated the values of k and sigma k. Using the formula, we can find the rotation factors. Now let us find the stiffness in the joint B. First, let us find for BC. Length of BC is 4. Let us apply that. For the stiffness of BC, we are getting EI. Now let us find the stiffness for BA. Length of BA is 4. Let us apply that. For the stiffness of BA, we are getting EI. Before finding the stiffness of BH, we have to find the stiffness for BE. Length of BE is 8. Let us apply that. The moment of inertia for BE is 2I. So in the formula, instead of I, we have to apply 2I. After the calculation, we are getting the stiffness for BE, which is equal to EI. To find the stiffness of BH, we have to divide the stiffness of BE by 2. Finally, for the stiffness of BH, we are getting 0.5 EI. Now let us find sigma k. For that, we have to add these three values. After adding, we are getting 2.5 EI. Now, using this formula, we can find the rotation factors in the joint B and the joint C. we have to make rectangles like these. Now let us enter the fixed end moments. M of BE is minus 96. M of CD is also minus 96. In the joints B and C, we have to add all of the fixed end moments. Except these two moments, all the other fixed end moments are 0. So in the joints B and C, when we add all of the fixed end moments, we will get minus 96. Now let us enter the rotation factors. For CB, the rotation factor is minus 1 upon 3. For CG, the rotation factor is minus 1 upon 6. For BC, the rotation factor is minus 0.2. For BA, it is minus 0.2. And finally, for BH, it is minus 0.1. Now, we are going to find the rotation contributions. In the joint B, we have three rotation contributions, M dash BC, M dash BH, and M dash BA. In the joint C, we have two rotation contributions, M dash CB and M dash CG. The formula to find the rotation contribution is summation of rotation contributions at far end plus summation of fixed end moments into rotation factor. First, let us calculate the rotation contributions in the joint C. First, let us find M'(CB). M'(CB) is located in the joint C. For the joint C, the fair ends are the point B and the point G. In the point B, initially the rotation contribution M'(BC) will be 0. In the point G, the rotation contribution will be always 0. So, for the summation of rotation contributions at fair end, we have 0 plus 0. The summation of fixed end moments is minus 96. The rotation factor for CB is minus 1 upon 3. Finally, for M'(CB, we are getting 32. For M'(CB and M'(CG), in the formula, all of the values will be same except the rotation factor. The rotation factor for CG is minus 1 upon 6. After the calculation, we are getting M'(CG). Let us apply the value of M'(CB) here and M'(CG) here. Now let us find the rotation contributions in the joint B. First, let us find M'(BC). For the joint B, the fair ends are the point A, the point H, and the point C. In the point A, we have a fixed support. In the fixed support, the rotation contribution will be 0. In the point H also, the rotation contribution will be always 0. In the point C, we have the rotation contribution 32. So, for the summation of rotation contributions at a fair end, we have 0 plus 0 plus 32. The summation of fixed end moment is minus 96. The rotation factor for BC is minus 0.2. Finally, for M'(BC, we are getting 12.8. For M'(BC, M'(BA, and M'(BH), in the formula, all of the values will be same except the rotation factor. The rotation factor for BA is minus 0.2. The rotation factor for BH is minus 0.1. After the calculations, we are getting M'(BA and M'(BH). Let us apply the value of M'(BC, M'(BA, and M'(BH). We have finished the first iteration. Let us start the second iteration. Let us find M'(CB). Now in the point B, we have the rotation contribution 12.8. We know that in the point G, the rotation contribution is 0. The summation of fixed end moments is minus 96. The rotation factor for CB is minus 1 upon 3. Finally, for M dash CB, we are getting 27.333. The rotation factor for CG is minus 1 upon 6. For M dash CG, we are getting 13.866. Let us apply the values of M dash CB and M dash CG. Now let us find the rotation contributions in the joint B. First, let us find M dash BC. We know that in the points A and H, the rotation contributions are 0. The rotation contribution in the point C is 27.333. The summation of fixed end moments is minus 96. The rotation factor for BC is minus 0.2. After the calculation, we will get M dash BC. To find M dash BA and M dash BH, we have to apply the rotation factors. After the calculations, we will get M dash BA and M dash BH. Let us apply the values of M dash BC, M dash BH and M dash BA. We have finished the second iteration. Let us start the third iteration. Let us find M dash CB. In the point B, we have the rotation contribution. Let us apply that. Then let us apply the summation of fixed end moments. The rotation factor for CB is minus 1 upon 3. Finally, for M dash CB, we are getting this. To find M dash CG, we have to apply the rotation factor. After calculation, we will get M dash CG. Let us apply the values of M dash CB and M dash CG. Now let us find M dash BC. In the point C, we have the rotation contribution. Let us apply that. Then let us apply the summation of fixed end moments. Then let us apply the rotation factor for BC. After the calculation, we will get M dash BC. To find M dash BA and M dash BH, we have to apply the rotation factors. After the calculation, we will get M dash BA and M dash BH. Let us apply the values of M dash BC, M dash BH and M dash BA. We can stop in the third iteration because in the second and third iterations, we are getting approximately equal values. The formula to find the final moments is fixed end moment plus 2 into rotation contribution at near end plus rotation contribution at far end. Let us make a table. In the table, first let us enter all of the members. Then let us enter the fixed end moments. Then let us enter 2 into near end rotation contributions. For AB, the near end rotation contribution is 0. So 2 into 0. For BA, the near end rotation contribution is 13.715. For BH, the near end contribution is 6.858. For BC, the near end contribution is 13.715. For CB, it is 27.422. For CG, it is 13.711. Now let us enter the far end contributions. For AB, the far end is BA. In BA, the contribution is 13.715. For BA, the far end is AB. In AB, the contribution is 0. For BH, the far end is HB. In HB, the contribution is 0. For BC, the far end is CB. In CB, the contribution is 27.422. For CB, the far end is BC. In BC, the contribution is 13.715. For CG, the far end is GC. In GC, the contribution is 0. Now let us find the final moments. For that, we have to add these two values. After adding, we are getting the final moments. The moment in BH can be taken as the moment MBE. The moment in CG can be taken as the moment MCD. In the joint C, for CB and CG, we are having different values. The values are slightly different. We can take average of these two values. I have taken the average of these two values and got 68.57. On the left side, we have calculated all of the moments. Now let us find the moments on the right side. The values of the moments will be same on the right side because of the symmetrical nature, but the directions will be opposite. For example, in the point A, for MAB, we have got a movement in the clockwise direction. That is why it is positive. So M of E should be acting in the anti-clockwise direction. So it should be negative. So to find these movements, we have to just change the sign of these movements. Here you can see the bending moment diagram for the columns. Here you can see the bending moment diagram for the beams. Now we are going to end this session. Thank you for watching this video.